So up until now in our study of trigonometry, we have used the definition of our trig functions to be able to find both sides and angles, but those have dealt specifically with right triangles. Now, what do we do how do we find sides and angles of triangles that are not right? In other words, how do we find angles and sides of what we call oblique triangles? So here I have two pictures. The first, a picture of what we would call an acute triangle, a triangle that has all angles are less than 90 degrees. And I have an obtuse triangle where one of those angles is larger than 90. In either case, both of these triangles do not include a right triangle, or a right angle, So how do we find then sides and angles if those properties of our definitions of trig only apply to right angles and right triangles? Well, that's where the law of sines comes in. So we're going to use that property to look at the law of sines today. So here I have the definition of the law of sines, and you can see that it is really just a ratio of the length of a side over the sine of that corresponding angle. So I have a length of side A divided by the sine of angle A would be equal to a length over the angle equal to the length over an angle. Now, when you work the law of sines, typically, let's go back down here, typically you would have something like this, where you're working with two ratios together, and when we do that, as long as I have 3 of these pieces of the 4 available, as long as I have 3 pieces available, I can solve for the missing value. So this is the law of sines, and we're going to look at a couple of examples and see how we apply it. In this first example here, we are given triangle A, B, and C. We are told both angles A and C, and then we are also given side C. Remember that when you're reading this, generally angle measurements are denoted by capital letters, and then side measurements are denoted by lowercase letters. Lowercase letters or sides fall across from their corresponding angle. So this is side C, falls across from angle C. Now, how do we use the law of sines to find all of the remaining missing pieces that we want? In other words, when you're given an example like this, you need to find out what angle B is going to be, as well as this side, little a, and little b. So we're going to start with our known ratio. This known ratio has to deal with angle C and side C. So we represent that as C over the sine of C is going to be equal to, and in this case I know angle A, so I'm going to talk about the sine of angle A, and I'm going to actually solve for side A. So we're going to end up solving in this first portion of it side A. So this is the ratio we're going to use, and we fill in the information that we know. We know side C is 25.3. We know angle C is 102.6. That's equal to side A divided by the sine of angle A, which is 28.8. Now, rearranging this equation, remember you can cross multiply across the equals sign, and since I want to solve for for side A, then I want A to be equal to, A is going to be multiplied by the sine of 102.6, because I'm going to multiply these two together, set that equal to the product of the other side, diagonal, which is 25.3 times the sine of 28.8. Again, solving for A, I'm going to divide both sides now by the sine of 102.6, sine of 102.6, and I can actually put this entire right-hand side over here into my calculator to be able to find out what A is equal to. So that's what we're going to try right now. Okay, so you can see that I did this in 2 steps over here in the calculator. I first multiplied 25.3 times the sine of 28.8, and then I divided that by the sine of 102.6. Rounding to the nearest tenth, I get 12.5 inches. Now I know what side A is, and I can find out what the remaining angle B as well as side B is going to be. So we have part of this done. Now I know 2 of the 3 angles of the triangle, so I'm going to use the sum of our triangles, the sum of the angles of a triangle, to find out what angle B is. I know that the interior angles of a triangle have to add to be 180, so if I take 180 minus angle A and angle C, I find out that angle B is actually equal to 48.6 by subtracting 180 and 102.6 and 28.8. We get 48.6. Now, that allows me to then be able to use again the law of sines to figure out what side B is. Now, I cannot use Pythagorean's theorem in this case to find the missing side over here, because Pythagorean's theorem only works on right triangles. So this is why we have to do the law of sines. So we're going to take our known ratio, which was what we started with right here, and we know that we have side C over the sine of angle C. That's equal to side B, because that's what I'm solving for in this case, divided by the sine of angle B. And that's how come we had to find angle B first, so I could apply it in this ratio. Now, side C again was 25.3 divided by the sine of angle C, which is 102.6. That's equal to side B divided by the sine of 48.6. So we solve this by cross multiplying, and we find out that B is actually equal to, or side B is actually equal to 19.4 inches, I believe is what we're working in. So you can see that in order to use the law of sines, you have to first have a known ratio. You set that equal to part of the second ratio, or the part you're trying to find. And that's how we're going to solve these examples using the law of sines.